All right, so we just looked at finishing frequency distribution. This was a rather elaborate one because we included not only the actual frequencies of each class, but their respective midpoints, the relative frequencies, and then the cumulative frequencies. Well, guys, these columns come in handy if you have to show things other than just frequency histograms, which we're going to look at next. Okay. So a frequency histogram is a nice way to visually see how the data is spread out. And it actually uses bars to represent the frequency of the data in each of those classes. So each class will have its corresponding bar, and the height of the bar will be representative of the number of data entries in that particular class. So the higher the bar, the more data entries in that particular class. Okay. So a frequency histogram, guys, is really just a bar graph. Okay. Now the horizontal scale is going to be quantitative and measures the data entries. So like in this example that we're using, out-of-pocket expense for prescription drugs, that horizontal axis will measure dollars. And then the vertical scale measures the frequencies of the classes. And then consecutive bars must touch. That's kind of the difference between, well, one of the differences between a frequency histogram and just a regular bar graph. A regular bar graph, the bars don't typically touch. And furthermore, the height of the bar typically doesn't represent the frequency. It represents some other numerical value. Okay, now the bars will touch at what are called class boundaries. Okay, we use class boundaries instead of class limits because if you look at these class limits right here, going from the upper class limit to the lower class limit of the next class, there's actually a gap right there. Okay, there's a gap of 1 because it jumps from 190 to 191. So what we typically do is we add a half step. We add and subtract a half step. So at a lower class limit, we subtract a half step. So 155 minus 0.5 would give us 154.5. Okay? And then the upper boundary, not the upper limit anymore, the upper boundary is going to be a half step above this upper limit. So it's going to end up being 190.5. And this 190.5, that's actually where the next lower bound starts. Okay? See, because if you take 191 and subtract a half step, you get 190.5. And then they just kind of go the same way. Add a half step to 226 and you get 226.5, etc. And to find the rest of these, you could just start adding 36 again because that's the class width. But this next one would be the previous boundary. And then this one would be 262 plus a half step, so 262.5. And that would become the lower boundary for the next one. And then 298.5. Oops. And that becomes the lower boundary. So you can see now there is no difference. There are no gaps in the upper boundary of the previous class and the lower boundary of the next class. There is no gap there. Okay, so that's the reason why these bars touch when you draw a histogram. And then continuing, this next one would be 334.5. This one would go to 370.5. And finally, this one would go to 406.5. Okay. All right. So let's look at a couple examples here. This is actually, I've got a histogram of this particular distribution that we've been working with. I'm going to zoom in though. Let's look at the one right here on the right, guys. Notice where this leftmost bar starts. It starts right here at 154.5. That's the lower boundary of that first class. And look at where this bar ends and the next bar begins at 190.5. That's the upper and lower boundary. Okay? And furthermore, you can see the height of each of these bars corresponds to the frequency of that particular class. So this bar has a height of 3, then 2, then 5, 6, 7, etc. So the nice thing about these histograms, guys, is I can look at this right here and I can get an idea of how the data is distributed, how these expenses are distributed. You can see most of the data is right here in the middle because this is where the 3 tallest bars are. So this contains the majority of the data. Something very similar over here is another histogram, except these bars have been centered on the midpoints. Okay, and we could have drawn the midpoints in here too if we wanted to, but sometimes you'll see it done like this as well, labeled with class midpoints, okay, instead of the class boundaries. All right, so anyway, that's what a frequency histogram is. And this is we're going to talk about distributions later on, but just look, once you make a frequency distribution and then turn it into a frequency histogram, that'll give you a really good idea of the shape of the distribution. Okay, so there are a few other ways, visual ways, or graphical ways that we can display data. The next one is called a relative frequency histogram. So this is really just like the other one. It says it has the same shape, the same x-axis. The y-axis still represents the frequencies. The only difference is that the y-axis measures the relative frequencies, okay, and not the absolute frequencies. I don't know if I have an example. No, I don't. But what would be happening here is the height of each of these bars would be the corresponding relative frequency. So like in this first class, that relative frequency was 0.1. And then the height of the second class would be 0.067. Okay? So you'll still get the same shape right here. It's just the y-axis is calibrated differently. That's the only thing with the relative frequency histogram. And then we have something called a frequency polygon. So it's a line graph that emphasizes the continuous change in frequencies. Here's an example of one. Okay, right here. And what you'll notice is that where each of these points are is where a midpoint was for each of those bars in the histogram. See, 172.5, another one here at 208.5, and then 244.5. Now you may be wondering, what about this 136.5 and then this one over here? What's actually happening here, guys, is, well, I think it may, yeah, it says it right here. You extend the left side to one class width before the first class midpoint, okay? So the midpoint of that first class is 172. Well, the class width is 36, so if I subtract 36 from that, that's where I get this value right here. And furthermore, the upper midpoint was 388.5. We look back up here. This is the upper midpoint. And you can see 36 above 388.5 would put us at 424.5. Okay, so the thing with a frequency polygon is that you put a point, and you put that point at that it has to correspond to the midpoint of the class, but also the actual frequency of that class. Okay, and then you go one class width below and one class width above, and that's where it actually rises and then falls back on the x-axis. But looking at this really has the same shape of this guy over here. Okay. Let's see. What else? The last thing I think is this cumulative frequency graph. This is also called an ogive. Okay? It's a line graph that displays the cumulative frequency of each class at its upper class boundary. The upper boundaries are marked on the horizontal axis, and then the cumulative frequencies are marked on the vertical axis. So let's look at an example of this. Okay, this tells you how to do it, but pretty much once you get your once you know what those class boundaries are and then the corresponding frequencies, that's really all you need. Okay, so you start right here at 0 at the lower boundary. And then you go up to the first upper boundary, 190.5, and that point has to have a height of 3. And then the next upper class boundary, 226.5, it's right here. And the frequency of that class is 2. So you've got 3 plus 2, which gives you 5. Okay, so the heights of each of these points are coming from, get back up here, the actual cumulative frequencies. So we're going along and we're accumulating frequency. So that's why this cumulative frequency diagram is increasing. Okay, and then you can see the cumulative frequency of the third class is 10. And the upper class boundary of that third class is 262.5. So at 262.5, this point has a height of 10. Okay, so to make Alright, I'm sorry about that, guys. My computer froze up and I had to shut it, and it's still not operating quite right, but we're virtually at the end of this section. I just wanted to add one last thing, that when you take into consideration this last class upper boundary, 406.5, it should have a height of 30. Right, because by the time you get to that upper class boundary, you have accounted for all 30 of those data values. And I think that's about it as far as the notes go. Okay, so again, I apologize for that. Anyway, I'll see you in the next section, 2.2. Okay.